Now, sample space diagram is a way of showing all of the possible outcomes of an event. Sometimes you can list them all. Sometimes there's a more systematic way of drawing them out, like making a chart or a lattice diagram. So for this one, where we have two different dice, we've got, you can imagine one of your dice is yellow and the other one is green. And so these are the possibilities you could get. Now notice some numbers happen more than once. Like for example, the number 4. You could get a 4 by rolling a 1 on the green dice and a 3 on the yellow dice. And that would be considered different than rolling a 1 on the yellow dice and a 3 on the green dice. And then that would be considered different yet of rolling a 2 and a 2. And so there's 3 ways to roll a 4 when you're rolling dice. Once you make your lattice diagram here, it's really easy to see that there's 36 in total. And all of these questions you can just see by pulling the numbers out from the chart. Don't even have to worry too much about using our formulas, our addition rule, or whether or not they're mutually exclusive. We can just sort of count from the chart how many of them are 6s. 2, 3, 4, 5. 5 out of the 36 are 6s. How many doubles are there? Well, 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. 6 out of the 36. And I'm not going to reduce these fractions right now because they make sense to leave them out of 36 because that's how many we had in total. Scoring less than a 6, so we got the 4 5s, 3 4s, is 8, 9, 10, 11. 11 out of the 36 are less than 6. Scoring 8 or more, or scoring an even number. And one of the things that I do in a situation like this, 8 scoring more than 8, well, I'm just going to circle all the ones that are more than 8. And then even numbers, I'm going to go and circle the ones that I haven't that are even. So then scoring more than 8 or scoring an even number, if we add those all up, 1, 2, 3, 4, 5, 9, 12, 14, 15, 16, 17, 18, 19, 21. Hoping that I added things up correctly, I get 24 out of 36. Or I could count the ones I didn't circle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and subtract those from 36 to figure out that it's 24 out of 36 that way as well. So a couple of ways that we can draw a sample space diagram. We can make a chart like we did the last one. That was, we can go heads and tails this way, and 1, 2, 3, 4, 5, 6. I don't think that's enough space. Spread that out a little bit. 1, 2, 3. There we go. And then we could label this as head 1, head 2, head 3, head 4, head 5, head 6, tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. So that would be one way of showing this. Another way of showing a sample space is with a tree diagram. tree diagram, you pick either one of your events to go first. So if I roll the dice first, 1, 2, 3, 4, 5, 6 would be my options there. Then, with the 1 could be heads or tails. With the 2 could be heads or tails. With the 3 could be heads or tails. With the 4 could be heads or tails. With the 5 could be heads or tails. With the 6 could be heads or tails. And then I would have H1, T1, H2, T2, H3, T3, H4, T4, H5, T5, H6, and T6. Probably in this case, that's our tree diagram. That lattice diagram is a little bit more compact. Can you imagine the last one that we did, rolling 2 6-sided dice, what your tree diagram would look like? You'd have your first 6, and then you'd have to draw 6 lines off of each one of those, so it gets really complicated quite quickly. Oh, just figured out a quiz that'll take you all class. You roll 5 dice. draw your tree diagram for that one. Either way, you get 12 total. Now we want to find the probability that in a single experiment you obtain a head and a number less than 3 on the dice. So now when we go to this, how many have heads and a number less than 3? There's only those 2. So we're going to get a probability for heads and less than 3, 2 out of 12, or 1 out of 6.